Hello everyone, let's continue to work on this cardiovascular disease model. Now we need to add some elements into the main class. The first element we would love to add into this main canvas is the table function. A table function is a function defined in a table form so that the user can simply make its continuous by interpolating or extrapolating. The user defines the function by giving a number of argument value pair so that anylogic builds the function based on the given data and then choosing interpolation type. A call of this function with some value passed as a function argument will return a value of this function. In our model, we need to define three different table functions. Let's do the first one, the depth probability table. Let's go to the agent palette and find the table function element and then drag this table function element into the main canvas. Let's go to the property views and specify the name of this table function. We will call it depth probability table. The next step, we need to specify the interpolation mode. In our case, we will select linear from this drop-down list. For the out of range option, we will select arrow, which means if the argument lies out of the feasible table, runtime arrow is raised, and a message box reporting about the arrow message will be shown on the screen. So the next step is to define the data for the data table function. In this data function section, there are three options. We can load this data from the existing anylogic database if you have so. The next option is you can just copy and paste from somewhere else and then just paste it. In our case, we will do it manually. Let's enter the data manually now. So now we need to rearrange this order of the argument. So we finished defined our first table function. Now we will define our second table function. We will name it stroke probability table. So for the interpolation option, we still select linear, and out of range, we will keep it as arrow option. But we still need to enter our data manually. So we finished define our second table function called stroke probability table. Then we still have one more. We will change the name to MI probability table and keep this as default and enter the data. Now we finished define our three table function to add second element into the main class. The second component we would love to add to the main class is called histogram data. What is histogram data? Histogram data can be used to collect output data, and the collected statistic can be visualized with histogram plot. In our model, we need to add three histogram data: life expectancy distribution, first MI age distribution, and the final one is the first stroke age distribution. Let's do the first one. Let's go to the analysis palette and then find the histogram data element, and then drag this histogram data into the main canvas. Now go to the properties view and change the name. So in here, you need to specify whether you want to calculate the CDF with the PDF. In our case, we just want the PDF, that's enough, so let us uncheck this option. And for the number of intervals, here we will enter 100, and the value range we will choose fixed, and then the minimum will be 0 and maximum will be 100. Why? Because our simulation runtime is from 0 to 100, so we know the minimum and the maximum value of this data. And then we need to choose fixed, and the 100 is the interval number. The next section is called data update. So we need to choose how you want this data element to be updated. In our case, we would like the life expectancy distribution to be updated automatically every year based on the model runtime instead of the calendar date. So we will select the update data automatically and then select use the model runtime. So please make sure your recurrencing time is 1 year because we want the life expectancy distribution data to be updated automatically every year based on the model runtime. So it's so easy to define the histogram data. Next step, we need to add the second histogram data. Let's drag this to the main canvas. So same as before, we will have 100 number of intervals and uncheck the CDF, and we would love our value range to be fixed, and the maximum will be 100, and update data automatically and use the model runtime. Make sure the recurrencing time will be 1 year. Next, we will add our third histogram data. Drag this from the analyst palette and change the name. Uncheck the calculate CDF option, enter 100 to the number of intervals, and then make sure your value range is fixed and the minimum is 0 and the maximum is 100, and make sure the data update automatically and use the runtime, the data runtime instead of make sure to use the model time instead of the calendar date. And then next we need to make sure the recurrencing time is 1 year. So it's so easy, we already add 3 histogram data into our main canvas. Now we need to add our third component to the main class, which is variables. Variables are generally used to store the result of model simulation or to model some characteristics of objects. These objects may change over time. However, we sometimes use a parameter. A parameter is normally a constant in a single simulation. When it comes to the question that when should we define a variable or define a parameter, the rule of thumb is to use a variable if you need to model some data continuously changing over time. And we will use a parameter when we need to model some parameter or attribute of an object change only in particular time. In our model, we set body mass index, the BMI, as a parameter because we assume each patient's BMI is unchanged during the simulation runtime. However, the number of patients having stroke, MI, or death may continuously change over time. Therefore, we need to define 6 variables in main class to store this number. The first one is the number of patients having neither stroke or MI. We call it number no event. The second one is the number of patients having MI. The third one is the number of patients having stroke. The fourth is the number of patients having both stroke and MI. The fifth is the number of patients dead. The last one is the cost variable, which indicate the accumulative aggregate cost. Let's define the number of no event first. Go to the agent palette and find the variable elements in this palette and drag this variable into main canvas. Change the name to number of patients having no event. We would love this type of variable to be integer because we are collecting the number of patients having neither MI or stroke. So the number is the integer. Then make sure it's accessed by the public. The second variable is the number of patients having MI. So change the name to number MI and then change the type to integer. That's it. The other one is number of patients having stroke. Change type. This variable will store the number of patients having both MI and stroke. Make sure you change the type of this variable into integer. This variable will collect the number of patients dead during the simulation runtime. Last one is the cost variable. Change the name to cost and then change the type into integer. So we finish defining our 6 variables. So far we have already created 3 data tables and 3 histogram data and 6 variables. For this data, we would love to use some plots to visualize to facilitate our analysis. So in our case, we have 3 histogram data. We need to create 3 histogram plot. So go to the analysis palette and drag the histogram to the main canvas. Place in the upper right corner and then go to the property view, change the name. In this box, we need to specify the histogram data we would love to visualize in this plot. So go back to this data and copy the name of this histogram data and then paste to the box of histogram and change the color for it. For this part, just leave as default. And this data updating option also leave as default, but now we need to change the bar's relative width to 100%, and then we don't want our vertical axis label to show in the plots. For the position and size, change this value. We don't want our legend to show in the plot, so just uncheck it. For the chart area, we also need to change this value. So that's it. You can see right here, we don't have any data populate in the plot yet because the life expectancy distribution is empty right now. Later we will use an event to update this life expectancy distribution data. So don't worry about it for now. Next, we will create another histogram to visualize this distribution. Same procedure as before, drag the histogram to the main canvas and change the name. For some color, you can enter the name of the color here. So we want to settle brown as this PDF color. Same as the first histogram, so we need to change the bar relative width to 100%, and we don't want this vertical axis label to show. And next, go to the position and size area, change this value. Same as before, we don't want the legend to show in this histogram. Change the value for the chart area. So for this one, same reason, because we don't have any data in this first MIH distribution now. Later then we will create an event to update the first MIH distribution so that this histogram will populate with data. Drag another histogram and place just below the second one and change the name. Go back to the data, use the data histogram data name, then copy to this histogram box. Change the color to red. Leave as default. Change the bar relative width to 100%. Same, we don't want to show the vertical axis label. And we also don't want to show the legend and change the position and size value. I thought. For chart area, do the same thing as the second and the first one. Change the value. We already create one variable called cost. In our model, we want to visualize this cost in a time plot. So let's go to the analysis palette right here and then find the time plot element right here and drag and drop this time plot to the main canvas. Place this time plot under the histogram and go to the property view. Change the name. We will call it Associate Third-Party Cost by Year. Go down to the data section, select value to be displayed on the chart. Give it a title called Total Cost. And the value we want to visualize in this time plot is the cost variable. And then change the color to red. We only want to visualize one value in this time plot, so let's delete this section. And make sure you want the data update selected and update automatically and use the model time. And make sure your recurrencing time is 1 year. This as default and go down the appearance. So we want to draw a line for it, so just leave as default. Now we need to specify the position and size value for this plot. We don't want to see the legend on this plot, so go down to chart area. Change the value for X offset and Y offset. Okay, my fault. My apology. We have already created a time plot to visualize the cost variable, but now we still have 5 remaining variables need to be visualized. For these 5 remaining variables, we will use time stack charts to visualize. So let's go to the analysis palette and find the time stack chart element and drag and drop to the main canvas and place it under the time plot and go to the property, change the name to CVD state by year. In the data section, we will select value and then the first variable we want to visualize this in this time stack chart is the number of no events. So let's copy this name and place it into this value box, which means we want the variable called number of no events to be visualized in this time stack chart. So give it a general title. Change the color, remember, and then the second element, second item we want to be visualized in this time stack chart is the variable called number of MI. Let's copy this name and then paste to this value box and also give it a general title. Change the color to golden. We have 5 variables, so add one more section here. Go back to the third variable, which calls number of stroke. Copy the name and paste to this value box and give a general name. Change the color so that we can differentiate different variable change over time in this time stack chart. Change the color to brown. And we still have one more variable left, which called number of patient death. Change the color to silver. So we already add our 5 data items into this time stack chart. So let's move down to the data updating option. Make sure your data will be updated automatically and use the model time, and then the recurrence time will be 1 year. In the scale here, in the scale section here, the time windows will be 100 model time units, but we need to change the vertical scale to fixed. We want the vertical scale from 0 to 1000 because we have 1000 population. So the number of patients that or the number of patients have both events or not having any events will up to 1000. The maximum number of the variable will be 1000. Change the horizontal axis label to none. And then we want our vertical axis to be on the left hand side. of the plot. Go to the position and size section, change the value for it. In this timestamp chart, we want to show the legend because we have 5 different variables, so we would love to have our legend to help us differentiate the plot. Now then go to the chart area, change the values. Now in this other one section, there are 2 options for time window moves. You can choose whether the chart time window moves according to the current model time continuously, or is moved only when new data points is adding to this chart as data become available. In our case, we will select as data become available. So the reason why this is blank is same as this 3 histogram, because we don't have data populate in this plot yet, because we need to add one more event so that we can use this event to update these variables and update this histogram data. Then we will have the data populate in this plot and charts. Next step, we can add a title and text in front of each plot and chart so that we can know which plot explain what kind of information to us. Let's do that. Let's go to this presentation palette and drag a line here, make it parallel to the first plot and move over. Change the color. And we can add a text here to give a title for this plot and chart. So we will give a title for this plot called Life Expectancy and CVD and cost statistic. We want this text in the maroon color, and we want to have larger and bolder. Next, we will give a text information for this plot and drag a text right here and in front of this plot. Then we will name it. Give a text right here. We call it Life Expectancy Distribution. Same, change the color, change. Let's do the next for the following plot and chart. This one, I think, it shows us the first MIH distribution, so we will name it This one can show us the information about first stroke age distribution. So let's move it upper and change the text. But this one is time plot for cost. So change the title to associate the party. This one tells us some CVD state statistic. So this has some statistics related to the number of patients having no events, the number of patients having MI, or the number of patients having stroke. So this statistic is associated with a CVD state. So we will give title. This color is not correct. Change to marine. So yes, that's it.